Here in session 93, we're going to be addressing the quadratic formula. And the quadratic formula is one of the more famous formulas within algebra and definitely one of the more helpful ones. And the reason for that is the quadratic formula can be used to determine what solutions exist and what those solutions are for any quadratic equation that there is. Up to this point, we've been using some different strategies for finding the answers to quadratic equations, but the quadratic formula will always work. First of all, we need to know what our quadratic equation is. It has to be in the format of ax squared plus bx plus c equals 0. If you have that quadratic equation, then the solution to that will be x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And that may seem like quite a mouthful to begin with, but as you work with it over time, you'll see that it's really not that difficult. But this formula, this quadratic formula, is so helpful that it is actually recommended that you memorize it. And I completely agree with that. That is one of the formulas that I remembered the longest, was that one. It's very helpful. Okay, let's take a look at an example here. 2x squared plus x minus 3 equals 0. That's our quadratic equation that's in the standard form. Before we go on and try to solve this using the quadratic formula, let's identify what a is. Remember, a is the coefficient of the x squared term. So what's our a down here? 2. The b is the coefficient of the x term, or the x to the first term. So what's b down here? 1. Because remember, 1 times x is the same thing as x. Don't be tempted to say that your coefficient is 0 here, because if it were 0, 0 times x would be 0 and you wouldn't have any x's. So your coefficient here for b is 1. And then our c here is our constant. And down here that corresponds to minus 3. So let's go ahead now and solve this quadratic equation using the quadratic formula. Let's rewrite x equals, we now need to determine what minus b is. Well, b is 1, so minus b is minus 1. Then we're going to have plus or minus, and then the square root of b squared. Well, b is 1, so we need to square that. Minus 4, I'm pulling straight from our formula here, times a. Well, our a is 2, so that's going to be minus 4 times 2 times c. c is minus 3. So that takes care of the top portion of this fraction. The bottom portion is going to be 2 times a. a is 2. Okay, at this point, we can actually start, now that we've plugged in our a's and our b's and our c's into this formula, we can start simplifying. So I'm just going to rewrite this and start some simplifying here. We have x equals minus 1 plus or minus the square root of, well, 1 squared is 1. Minus 4 times 2 is minus 8, and minus 8 times minus 3 is plus 24. So that's going to make this a plus 24. That takes care of the top part. The bottom part is 2 times 2, which is 4. Simplify even further here. X equals minus 1 plus or minus the square root of 1 plus 24. Well, 1 plus 24 is 25. What is the square root of 25? Well, it's 5. So what we can have here now is minus 1 plus or minus the square root of 25, which is just simply 5, all over 4. At this point now, this might be good enough for many situations, but let's go ahead and take it out even further to find out what our two different values are. Let's start with our plus. Minus 1 plus 5 is 4. 4 over 4 is 1. So we know that one value for x that works is x equals 1. Let's do the minus part now. Minus 1 minus 5 is a minus 6. Minus 6 over 4 reduces to minus 3 over 2. So the second value for x that works is minus 3 over 2, or minus 3 halves. And I'm not going to go ahead and write out the checks or the double checking for this, because it gets a little bit consuming as far as our whiteboard here. But you could stick a 1 back here and perform mental math. Does 1 work back here? Well, let's stick in a 1. 1 squared is 1. 1 times 2 is 2. 2 plus 1, because x is 1, is 3. 3 minus 3 is 0. So that does in fact work there. If we stick in a minus 3 halves, let's see if we can do this in our head. Minus 3 halves squared. Well, first of all, a minus times a minus is going to be a positive. So minus 3 halves times minus 3 halves is positive 9/4. Positive 9/4 times 2 would be a positive 18/4. Then what we're going to add to that is a minus 3 halves. And then what we're going to do after that is subtract the 3 from it. Well, our first term, our 18/4, actually reduces to 9 halves. So what we really have here is 9 halves minus 3 halves. 9 halves minus 3 halves is 6 halves. Well, 6 halves reduces to 3. And then we're left with 3 minus 3 equals 0. So we can see that these two do in fact check out. Let's take a look at one more. Here's our quadratic equation. 3x squared plus 4x minus 5 equals 0. So we're going to use our formula. X equals, well, before we even do that, sometimes it's helpful to determine what A, B, and C are before you even start this. If it's more helpful for you to do that, you can do it that way. What's our A? Well, remember, A is the coefficient of our x squared, so that's going to be 3. Our B is the coefficient of our x to the first term, so that's going to be 4. And then C is our constant there. C is going to be minus 5. So if it helps you to write those out ahead of time, the values for A, B, and C, by all means, go ahead and do it. With that done, let's go ahead and use our quadratic formula. Our quadratic formula is x equals minus b. Well, minus b would be a minus 4. B is 4, minus b would be a minus 4. Plus or minus the square root of b squared. Well, what is b squared? B is 4. B squared minus 4 times A is 3, times C, and C is minus 5. Then all of that is going to be over 2 times A, and A is 3. So here we have minus b plus or minus the square root of b squared minus 4ac all over 2a. Now let's go ahead and simplify with these values for a, b, and c that we inserted over here. X equals minus 4, I'm just simply rewriting this, plus or minus the square root of, well, 4 squared is 16. Minus 4 times 3 is minus 12. Minus 12 times minus 5 is a positive 60. And then all of that is going to be over 2 times 3, which is 6. Let's go ahead and take this simplified a little bit further. Minus 4 plus or minus the square root of 16 plus 60 is 76, all over 6. Now we could factor out using our square root principles from before. 76 is actually 19 times 4, and 4 is a square. But I'm not going to go too far into that right now because I don't want to confuse what we're trying to do with the quadratic formula. But we could in fact take that out even further by factoring out that 4. But I'm not going to do that right now. So then, we have x equals minus 4 plus or minus the square root of 76 over 6. So if I were to ask us what are our two values, well, they would be minus 4 plus the square root of 76 over 6. That's our first value. The second value would be minus 4 minus the square root of 76 over 6. These are the two answers to our equation, our quadratic equation. If we were to stick in these values, you could actually use a calculator to determine what the value of the square root of 76 is. And remember, you're not going to get an exact answer because the square root of 76 probably goes on indefinitely. So you're not going to get an exact value of 0, but you'll get very, very close to it. Because remember, most of the time when we use a calculator to determine the square root of something that does not have an even answer, it has decimal places after it, very, very often those decimal places go on very long, if not indefinitely. So then these two are in fact the answers or the solutions to the problem. And they were solved using the quadratic formula. Quickly, the solutions to any quadratic equation can be determined by using the quadratic formula. It's an extremely helpful formula, and you really should memorize it. And then lastly, the quadratic formula states that if you have a quadratic equation, such as ax squared plus bx plus c equals 0, then x is going to equal minus b plus or minus the square root of b squared minus 4ac all over 2a. That finishes up then session 93 on the quadratic formula.